Hello students, welcome to my next lecture on construction of analytic function. Myself Dr. Arulprakasam, Department of Mathematics, SRM Institute of Science and Technology, Katangutu. Last two lecture, I explained what is analytic function based on problem, also I discussed, and then necessary and sufficient condition also discussed. And a second lecture, I explained harmonic function and based on problem also I discussed. Today class I'll explain construction of analytic function and based on this problem. So construction of analytic function, suppose real part or imaginary part is given, then how to find out the corresponding analytic function f of z. So this method defined Milne-Thomson. So that's why it's called as Milne-Thomson method. So here I mentioned working rule. Suppose if a real part u is given, then how to find corresponding analytic function f of z. So the rule is mentioned here. First, find your first derivative with respect to x and y. Suppose u is given, that means real part is given, and then replace x to z and y to 0 in our first derivative ux and uy. Just to find out ux of z comma 0 and uy of z comma 0. And you write this formula f dash of z nothing but ux z comma 0 minus I uy z comma 0. It is by using CR equation I'm getting this one, and this is our corresponding analytic function formula. If you want f of just one time integrate we'll get f of z. So this is the formula. Real part is given, now how to find corresponding analytic function. Second one, suppose imaginary part v is given, then similar way find your first derivative with respect to x and y, and then replace instead of x to z, y to 0. Then we form this function f of z by this form. This is the rule. So no need to memorize this rule. So we can do the problem in easy manner. Suppose I can consider one problem. So here question is find the analytic function whose real part is given. U is given. It is real part of f of z given. So just everyone you know very well the standard notation. Just I mentioned here. We know that what is the suppose consider capital F of z. It's a complex function u plus iv. That means u is a function of x comma y. V is a function of two variable function. So what is the derivative of z with respect to x? What happened? F dash of z nothing but u is function of x comma y. Find ux first derivative with respect to x plus I is constant and v is function of x comma y. First the derivative with respect to x means vx. Otherwise with respect to y means, so f dash of z I can write either ux plus ivx or f dash of z uy plus ivy, differentiating with respect to x and differentiating with respect to y. This is known result, known notations, basic notation. By the rule we are forming this analytic function. So what about here? I know f dash of z ux plus ivx, and what is the problem here given? I try to get here only real part is given. So here v is there. So how to form related u in terms of v? That is for our CR equation in the analytic function part. You studied in the analytic function part CR equation. So what is the relation? Ux is equal to vy and uy is equal to minus vx. Here I want to replace vx because the real part is given u. So I can form the derivative f dash of z in terms of u only. So here v of x, vx I can relate it to in terms of u by the CR equation. So I know what is our vx here minus vx uy equal to minus vx. From that I am writing vx is nothing but minus uy. So here I can replace vx to minus uy. So our f dash of z nothing but ux minus ivy. So because here u function given, a real part of f of z is given. From that I formed a derivative of f dash of z ux minus I uy. So this is our rule here mentioned. So no need to memorize this one. By the CR equation, I can form that formula. Okay. So if after that, in our UDS, in the place of x, I can replace to z, y to here ux of x comma y. It's a derivative, first derivative with respect to x. It is function of x comma y. In the place of x, I can replace to z, y to 0. So I am getting f dash of z. So if you want to f of z, one time integrate will get, this is the general formula here I mentioned. So by the formula I am getting the corresponding f of z. So what is the rule here? A real part is given. First find your first derivative with respect to x. See this function. So first differentiate with respect to x means what happened? Here x cube differentiation value 3x square. Here minus 3y square constant, x differentiation value 1. So 3 constant, x square differentiation value 2x, so 6x. This y, there is no x variable. So if you are partial differentiate with respect to x means these are all constants, so the value is 0. So I got first derivative with respect to x. What is the second condition? So in our first derivative, in the place of x, I can replace to z. In the place of y, I replace to 0. So what happened? Just I am getting. So here 3z square, here 0, here in the place of z, I am replacing. In the place of x, I am replacing z. So I am getting first derivative with respect to x. So 3z square plus 6z. Similarly, find your first derivative with respect to y in our given u function. So differentiate with respect to y means here constant, because if you are partial differentiating with respect to y means if you can treat as y is constant. So x cube constant 0 minus 3x here constant. So y square differentiation value 2y. So what happened here? So 2 into 3 are 6 minus 6xy. Here constant because it is differentiated with respect to y. So we can treat as constant 0. This one's minus 6y plus 0. So what happened? In the place of x, I can replace to z, y to 0. Here x replace y 0 means it will be 0. Y replacement. So our uy of z comma 0 value 0. So write your formula. So our if you want to f of z, integrate ux of z comma 0 minus I uy of z comma 0 into dz. So okay, so just to substitute this value, in ux of z comma 0 value 3z square plus 6z minus I into uy of z comma 0 value 0 plus c. So once integrate with respect to z, what happened? So 3z square into dz value z cube by 3 plus 6 z square integration value z square by 2 plus constant. So I can simplify here. So z cube plus 3z square plus c. This is for our given corresponding analytic function f of z. This is the rule. So real part is given. So what is the rule? Real part is given. First find first derivative with respect to x and first derivative with respect to y. So I am getting ux and uy. Second replace x to z, y to 0 in the first derivative ux and uy. I am getting ux of z comma 0 value and uy of z comma 0 value, and substitute this formula. What is the formula? F of z is equal to ux of z comma 0 minus I uy of z comma 0 into dz plus c. You know how to get this formula. By here I explained. No need to memorize the everything. So you know everyone, analytic function f of z general form is u plus iv. U and v is a function of x comma y, right? And then first derivative f dash of z nothing but ux plus ivx. I need here problem is given, only real part is given. I have to write out in terms of u alone. So that's why here imaginary part is given. By the CR equation, I can replace v in terms of u. So that derivation part is explained. Following this formula, easily you can solve any real part is given. Easily you can get corresponding analytic function. So I'll move on another problem. So what is the here? It is imaginary part is given. So imaginary part is given how to get corresponding analytic function. The same rule we can follow. No need to memorize the formula. So you know f of z Okay, f of z u plus iv by the formula find your dash of z in terms of just form in terms of v, because we imaginary part is given. So on form f of z, this is the formula. Following this formula we will get very easy manner the corresponding analytic function. So here what is the problem? V is given, so x power 4 minus, like that, minus 6 x square y square plus y power 4. So what is the rule? First to find your first derivative with respect to x and the derivative with respect to y. So I am differentiating with respect to x, we can treat as y is constant. So x power 4 differentiation value 4 3 x cube minus here 6 y square constant, at y square differentiation value, sorry, x square differentiation value 2x, here y constant 0. So in the derivative function with respect to x, replace x to z, y to 0. So here 4z cube, this time will be 0. So this is our vx of z comma 0. And similar way find derivative with respect to y. Here it is constant 0. So 6x square constant, y square differentiation value 2y. This one plus 4y cube. So here I can replace x to z and y to 0. This 0 na everything 0. This also 0. So I am getting vy of z comma 0 0. By the formula, it is by the Milne's method or Milne-Thomson method, f of z nothing but vy of z comma 0 plus I vx of z comma 0 dz plus c. How I am getting this? By the formula f dash of z. Okay. So I am replacing vy of z comma 0 value 0, vx of z comma 0 4z cube into dz plus c. I mean, once integrating, it is 0. So I constant 4 z cube integration value z power 4 by 4 plus c. So 4 4 cancel. Our answer f of z nothing but I z power 4 plus c. This is our corresponding analytic function. So real part is given, use the formula. Imaginary part is given, you know how to get corresponding analytic function. Try these two problem for following the method. Another third method one is, suppose the real part is given, you know how to get corresponding analytic function. Imaginary part is given, by the following method you can get corresponding analysis. The third method is, suppose the combination and the difference are sum of two real part, suppose u plus v and u minus v. This one that difference or some function is given, how to get corresponding analytic function. So u is the real part and v is imaginary part. The sum of real part and the imaginary function value given are difference of these two harmonic function value. U and v also, you know, harmonic function, right? Sum of two harmonic function value is given, or difference of two harmonic function, some constant form a u plus bv. That combination form is given. The how to get corresponding analytic function. It is very easy. We should do some uh, conversion form. By the method we will get the solution. So I'll do one problem. For example, suppose it is most of the time repetition question. Find analytic function f of z. The sum u plus v. The function is given sine 2x divided by cos h 2y minus cos 2x. Either some textbook given in this form. Otherwise, the same thing I can simplify. You know, cos h 2x e power 2y cos h 2y nothing but, you know, cos hx e power x plus e power minus x divided by 2 by the formula, right? Cos hx I can write e power x plus e power minus x divided by 2. By I am applying this formula here, it will come different way of the same problem. Okay, so e power 2y plus e power minus 2y divided by 2, take LCM means 2 cos 2x. It will the same, both are the same method, same problem, only modification method. So this is the most of the time repetition question. So I will do this problem. What happened here? Two harmonic function, sum of two harmonic function values defined. So they are asking find this corresponding analytic function f of z. So how to, in this case of problem given, how to solve this problem? By conversion method. So you know everyone, f of z is equal to u plus iv, right? And just I can multiply I on both side. In that equation 1 I am getting I f of z iu minus I into I square value minus 1, so minus v. So and for adding these two equation we'll get one new equation, one new function capital f of z is equal to u plus IV. Here I am taking this one capital U, this one capital U, this is capital V, this is capital F of Z. I am getting one new construction function, capital F of Z is equal U plus IV. So what is our capital U? Here I mentioned difference value. Capital V, sum of value. What is the meaning? Capital F of Z real part is nothing but capital U. Imaginary part is nothing but difference. I mean sum of two harmonic function is imaginary part of F of Z. Difference of two harmonic function is real part of capital F of Z. So here in the problem, which one form is given? Capital V. It is sum of two harmonic function structure is given. Capital V U plus IV. What is the meaning? So just that given problem converting in this manner. So capital F of Z imaginary part is given. Then how to construct corresponding analytic function capital F of Z. Then capital F of Z converted to small f of Z. That's it. So capital V is given, right? So what is the meaning? You know everyone, capital F of Z by the Milne formula Vy Z comma 0 plus, so capital F of Z is given now. What is the meaning? Vy Z comma 0 plus I Vx of Z comma 0, right? How I am getting this one? See, this is the formula, right? This F dash of Z. See, F dash of Z By Z comma 0 plus I Vx Z comma 0. So same thing here. Capital F dash of Z Vy Z comma 0 plus I Vx of Z comma 0. If you want F of Z nothing but one time integrate Vy of Z comma 0 plus I Vx of Z comma 0 into Bz plus C. So same method we can follow. Capital V function given. First to find your first derivative with respect to x. So what is the meaning? It is u by v form. It is u by v form. So formula v square v into u dash sin 2x differentiation value cos 2x into 2 minus by the formula. So u into v dash cos h2x differentiation cos h2y. If you are differentiating with respect to x, we can reduce constant 0 cos 2x differentiation value minus sin 2x into 2. Okay, and then I can substitute in the place of it is x comma y, in the place of x to z, x to z, y to 0. So here cos 0, y to replace y to 0, cos 0 value 1. Here cos x to z, cos to z into 2 x to z, 2 cos 2 z minus 2 sin, here what do you mean by here? 2z, here 2z. So nothing but 2 sin square z. See here 2 replace 2, here z, here z. What happened here? Sin 2z into sin 2z, sin square 2z, 2 is there. And 1 here, put y to 0, cos 0 value 1. So 1 cos 2z whole square. Now I can simplify here. What happened here? So just I can multiply 1 into cos 2z, nothing but 2 cos 2z minus 2 cos 2z into cos 2z, cos 2 cos square 2z minus 2 sin square 2z. So then I can simplify again. So 2 cos 2z. So here I have 2 common. So I am taking minus 2 commonly outside. Here cos square 2z plus sin square 2z. So what is the meaning? You know this. It is a very standard trigonometric formula. Cos square theta plus sin square theta value 1. So minus 2. I'm taking commonly minus 2 outside. So here I have 2. So minus 2 means 1 minus cos 2z. Here numerator side and denominator side I have 1 minus cos 2z whole square. I can get one part here. Denominator. So I can simplify this. I am getting minus 2 divided by 1 minus cos 2z. Okay. You know one more formula. So cos 2 theta nothing but cos square theta minus sin square theta. Otherwise cos 2 theta 1 minus 2 sin square theta. So here 1 minus cos 2 theta. Here I have So 1 minus cos 2 theta, I can replace 2 sin square theta. So here 2 sin square theta. Instead of this, I can replace 2 sin square theta. 2 to cancel. 1 by sin square theta nothing but cosecant square theta. So it is our Vx of z comma 0. It is imaginary part only given, right? It is V. It is V of Vx of z comma 0. And I also find your first derivative with respect to y, the same formula, v square v into differentiate with respect to here x, so 0 minus sine 2x, now differentiate with respect to y, cos h2y 2 sin h2y, this value 0, then replace x to z, y to 0. So what happened here? So y, I'm replacing 0 here, sin 0 value everything 0, so 0 numerator 0, denominator always 0. So here 1 I'm getting 0 by anything 0, so by z comma 0. So by the Milne's formula, capital F of z value nothing but integral vy of z comma 0 plus I vx of z comma 0 plus c. So I once substitute this value, it is nothing but minus cosecant square z dz plus c, this value 0. So once integrate, I am getting capital F of z value I into cot z plus c. So, but it is not our corresponding analytic function. So, it is our corresponding analytic function is small f of z. What is the relation between these two? So, simply replace capital F of z to small f of z relation. 1 plus I is into small f of z is equal to I cot z plus c. So, just here it is complex number divided by on both right hand side. So, small f of z nothing but I divided by 1 plus I into cot z plus c divided by 1 plus I. We can stop this up to this. Suppose if you want to simplify again, we can simplify this form. So it is I divided by I plus I, conjugate, take conjugate. So 1 plus I divided by 2 cot z. So I am taking c dash or c1. Here c1 nothing but c divided by 1 plus I. So these three method is most of the time general should ask in our questions. So it's very easy, we can in the very easy manner you can solve this problem. The real part is given how to construct corresponding analytic function, imaginary part is given how to construct corresponding analytic function, and the difference or sum of two harmonic function is given how to construct corresponding analytic function. Only these three kind of problem is there. So solve number of problem and practice. So here list of problem I given, try to solve and practice this construction of analytic function. Thank you students, we'll see you next class.